Hello students, welcome to Numerical Methods and Integral Transform course. I am Praveen Kumar. In this lecture, I am going to be discuss about unequi space data and Lagrange's interpolation. In the previous lectures, we discussed about equally spaced data. So, basically, the data is classified to two categories. One is equally spaced data, then the second one is unequally spaced data, or we can also call it as unequi spaced data. So, simply if the provided x values having difference is same, successive value difference. So, simply x1 minus x0 is same as x2 minus x1. So, x3 minus x2 same. So, all successive x series values are equally distributed, then we say that the data is equally spaced data. Where unequally spaced data is, so that x value is not evenly spaced, or simply x1 minus x0 is not same as x2 minus x1. At least one of the difference between the two successive values of x series is not same. We say that unequally spaced data. So, in the equally spaced data, as you know, we discussed about the forward differences, backward differences, central differences. In the forward, Newton forward we discussed in the last session, the previous lectures. So, in the backward area, Newton backward. In the central also, in the previous lecture we discussed about Gauss forward, Gauss backward. Where in the unequally spaced data, there will be one and only one method we have, that is Lagrange's interpolation. There is a lot of methods, but according to our course, we have one method, that is what we are calling as Lagrange's interpolation. So, how we are going to be find the Lagrange's interpolation is, so you have something values x0, x1, x2, the respective y values y0, y1, y2. So, to find out any value lies inside or maybe outside. If it is an inside, we are going to be find the value using of the values. If it is lies outside, we are going to be estimate the polynomial. We are going to be estimate the polynomial. So, if it is lies inside, so finding that value using of this particular formula. The formula is x minus, so x minus except this x not remaining values. So, just it is related to first term related to x naught. So, first term related to x naught. So, therefore, x minus x1, x minus x2 divided by the denominator, whatever this we excluded in the numerator, that term minus remaining all the terms x minus x naught minus x1, x0 minus x2 into that respective function value y naught. So, this is, let us assume it is related to the first term. Same way, let us assume to the second term is related to the second point. So, except this x1 remaining all terms x minus x0, so x minus x2 divided by, so x1 minus x0, x1 minus x2, that respective function value y1. So, now based on the number of points, we are going to be extend the formula. So, there are 3 points, we are going to be get obviously 3 terms only. So, x minus x0, x minus x1 divided by whatever we excluded. So, that point x2 minus x0, so x2 minus x1 into that respective function value is y2. So, this is a way we need to be find that unknown value. So, it is for unequally spaced data, we are going to be use this particular formula. Now, we will take one question, we will discuss how we are going to be find. Look at, so given some u0 is equal to 580, u1 is 556, u2 is 520, u4 is 385. Find u3. So now we need to be construct the table wise so that we'll understand easily, where the function is u suffix x, where putting x is equal to 0, that respective function value is 580, which meaning of the given data. When x is equal to 1, so that respective function value is 556. When x is equal to 2, so the function value is 520. When x is equal to 3, which is not given, that we need to be find. So that we need to be find. So when x is equal to 4, function value is 385. So this 3 is lies inside the table. So inside the table, the concept is called interpolation. So now we need to understand easily, just I am giving the notations to this: x0, x1, x2, x3. Respective function values u0, u1, u2, u3. Now we need to be substitute in the formula. So the formula, as I said, f of x is equal to x minus, just now I said x minus x1, x minus x2, x minus x3 divided by x naught minus x1, x naught minus x2. Like in the previous slide, I have written x minus x3, that respective function value is u naught or y naught. So like this, for 4 terms we need to be right. So now I am going to be substitute in that f of 3, or you can also write it as u3. Okay. So x minus x1, where x, what is x? Whatever the value we are finding, that will be called x. So 3 minus, except the first value, remaining all. So 3 minus 1, simply 3 minus 2, 3 minus 4 divided by whatever we excluded in the numerator, that minus remaining all terms. So 0 minus 1, simply 0 minus 1, 0 minus 2, 0 minus 3, like 0 minus 1, 0 minus 2, 0 minus 4. So 0 minus 1, 0 minus 2, 0 minus 4, that respective function value. What is this respective function value? Is 580. So this is belongs to the first term. Similar way, second term. So second term is same, x minus, what is x? X minus, except this one, remaining all terms. So 3 minus 0, 3 minus 2, 3 minus 4. Denominator, whatever we excluded, so 1 minus 0, 1 minus 2, 1 minus 4, like that. So 1 minus 0, 1 minus 2, 1 minus 4, that respective function value is 556. This is called the second term. So now the third term is plus, so third term is belongs to 2. So therefore except these 2, remaining all terms. So 3 minus 0, 3 minus 1, so 3 minus 4 divided by, so whatever they excluded, the term minus remaining all the terms. 2 minus 0, so 2 minus 1, 2 minus 0, 2 minus 1, 2 minus 4. That respective function value is already given in the data, that is 526. So third term is done. So similar way, we need to be, there are the fourth term, one more term is there. So except this term, remaining all, 3 minus 0, 3 minus 1, 3 minus 2 divided by, so that I am just writing this term here, it is not visible on the screen, so just I am writing here, plus 3 minus 0, 3 minus 1, 3 minus 2 divided by, so this particular term minus remaining all the terms, like 4 minus 0, 4 minus 1, 4 minus 2 into that respective function value is 385. So these you need to be simplify, like f of 3, 3 minus 1, 2. So 3 minus 1, 2, 3 minus 2, 1. So 3 minus 4 minus 1, like minus 1, minus 2, minus 4 into respective function value 5. Like this, we need to be simplify the second term, third term, fourth. term. So simply just we need to be type in the calculator, simplified. So where this 3.3 is obviously located in this answer also, obviously it is greater than 385 and less than 520. Our answer is, because it is when 2 value 520, when 4 value 385. So it is obviously decreasing the value, it will be lies in this. So if you simplify the answer, you are going to be get something 465.25. So this is only when the data is unequally spaced, we are going to be use this particular Lagrange's interpolation formula. So one more advantage of this Lagrange is also, if the data is equally spaced also, we can able to use. So Lagrange's we can able to use for equally and as well as unequally. That is what the extra advantage with this Lagrange's interpolation, right. So similar way we can also find this Lagrange's interpolation for finding the polynomial. If you see the previous one, the 3 is located inside. So given data is something 0, 1, 2, 3. If you want to be lies inside the table, it may be 2.1, 2.3, anything lies between 0 and 3, you can call it as interpolation. Sometimes you want to be find outside the value, it may be 4, it may be 5, it may be 6. That is one thing. The other thing is, if you want to be find more values, if it is only one value, we can able to substitute the formula once. Sometimes I need to be find 2 or 3 values, f of 2.1, f of 2.8, f of 2.9, something like more values required. Then the technique we are going to be use, once we find the polynomial, using of this polynomial, we can evaluate n number of values easily and quickly. That is what the advantage. So find the interpolating polynomial for the following data, we need to be use the appropriate formula. So we need to be estimate whether the given data is equally or unequally spaced. So based on that we need to be decide. So if the given data is, look at that, this is x0, this is x1, this is x2, we are checking the difference, x1 minus x0, 2 minus 1, 1, okay, x2 minus x1, minus 4, minus 2, minus 6. So both are not same. So therefore given data is not equally spaced, or we can also call it as unequally spaced. So if it is unequally spaced, we are going to be use the Lagrange's interpolation to evaluate that particular polynomial. If it is equally spaced, obviously this Lagrange's is not required. Either you can use the forward, Newton forward, Newton backward, Gauss forward, Gauss backward, anything is fine. But it is unequally spaced. So there is only one option according to our course, Lagrange's interpolation. So the formula is same. So only in the place of x, previously we substituted value. Now where the x keep as it is, we need to be simplified. So now we are going to be use the Lagrange's interpolation formula, to evaluate that particular polynomial. So the formula is, so there are 3 points obviously. So first one is except x0, x minus x1, x minus x2 divided by, so x0 minus x1, x0 minus x2, that respective function value, either you denote f of x0 or y0, anything is okay. So first term. Similar way second term, x minus except x1, so x minus x0, x minus x2 divided by x1 minus x0, so x1 minus x2, that respective function value we are denoting simply with y1. So the same way the third term, so except this value, remaining all the terms, x minus x0, x minus x1, denominator, so x2 minus remaining all the terms, so x2 minus remaining all the terms. x2 minus x0, x2 minus x1 into that respective function value, just I am denoting with y2. Either you can write f of x2 or y2, anything is okay. Now we are going to be substitute in that particular formula. So where f of we require, so we require polynomial. So therefore x I am keeping as it is, we are required to find the polynomial f of x. So f of x is equal to x minus x1, where x1 we have denoted 2. So x minus x2. So x minus or minus plus 4 divided by x naught. So simply, so 1 minus 2, 1 minus 4 in the denominator. 1 minus 2, 1 minus 4 into respective function value. Respective function value is 3 plus second term x minus x naught, where x naught is 1, x minus x2, where x2 is 2, x minus 2 divided by x1 minus x naught. So 2 minus 1 and x1 minus x2. So 2 minus 2 minus or minus plus 4 into respective function value is y1. Respective function value is y1, that value is minus 5. Minus 5. Now, so simply the third term just I am writing below, x minus except this x2. So therefore x minus x naught. X naught we know it, it is 1, and x minus x1, where x1 is 2. X minus 2 divided by x2 minus x naught. Simply 4 minus 4 minus 1. So minus 4 minus 1, then minus 4 minus 2 into respective function value is 4. Just we need to be simplify this and we are going to be get the particular answer. So look at, so this we need to be multiplied this x square plus 4x. So I'll be write in the next slide. So or else just simplify, you are going to be get this particular solution, x square plus 4x minus, so 2x minus 8 by, so 1 minus 2 minus 1, it is minus 3, minus 1 minus 3 is, yeah, so this is minus 1 minus 3 is 3. So like this we need to be simplified. So second term x minus 1 into x minus 2. So therefore x square minus 2x minus x plus 2 divided by, here into 3 is there, 3 get cancelled. Second term, so 2 minus 1 1, 2 plus 4 6, so 6 into minus 5. Like this even the third term. So we need to be simplify and take x square common and simplify. So you are going to be get some polynomial as minus 1 by 10, 13, so minus 1 by 10, 13x square plus 41x minus 84. So the previous three terms, if you simplify, first term and second term, third term also, like third term if you see, x square minus 2x plus 2 divided by minus 5 minus 8 into 4. So like this you simplify, you are going to be get that particular result as polynomial. So this is what we are going to be use the Lagrange's interpolation. So Lagrange's interpolation is meant for, so use unequispaced data. So in the unequispaced data, there are first one may be finding the value, second one may be finding the interpolating polynomial. So this is exclusively for unequally spaced data. So in this lecture we discussed about Lagrange's interpolation. In this lecture we discussed about Lagrange's interpolation. In the next lecture we are going to be discuss about curve fitting, right? Thank you.